Okay, so today we're looking at solving right triangles, some application questions that involve right triangles. And so a couple things I want to review with you first. One is significant digits. So significant digits are a way that we introduce the precision of a measurement. And we're not going to look at this extensively as we do in physics or in chemistry, but just a quick review on what you need to keep track of. Basically, you want to, in this class at least, on the side links, keep the same number of digits that are in the measurements of the sides. So let's review, I guess, some of the ones that you count and don't count with some different numbers. So let me make a quick little table. And let's just run through some different numbers and the number of digits that are significant in that. So if we start with, let's start with the number 0.042, 42 thousandths. The 0 is a place value holder, so we don't count in this case. The only two we count would be the 4 and 2, so this would have two significant digits. If we looked at 0.005, well, again, the two zeros in front of this are placeholders. It's 5,000, so this would only have one significant digit. We would round our answers to 1. 20.5, because this zero is between two significant digits, it does count. It doesn't just hold a place value. And so this would have 3. When we add zeros to the end after the decimal place, and they do not change the value. This is 6 with or without these 3 zeros. And so the only reason we add those is to show precision. We would count all 3 of those zeros. And so this one would have 4. But in the number 9,200, these zeros are not significant. They hold place value. And so this would only have 2. Now, the other thing we're going to add here is the significant digits in angles. Okay, so kind of as the rules of thumb, I guess I want you to follow on this. We have a little table here. This first column will be the number of significant digits and this is in the sides. Okay, so in the sides of the triangle, how many significant digits we have in there. And then this column is the precision of the angles. How many we're going to keep in the angles when we find the angles. Because we'll be finding in this section both the side length and the angles. Okay, so if we have 2 significant digits in the side lengths, then we're going to round the angles to the nearest degree. So 2 in the side length, nearest degree. If we have 3 significant digits in the side lengths, then we'll go to a tenth of a degree. And finally, if we had 4 in the side length, then it'll be the 100th of a degree. Okay, 100th of a degree. So, kind of some rules to follow. And I'll just run through a couple of questions, type of questions you're going to have on the assignment. So basically, let me get this written down. Okay, so you're basically given parts of a triangle and want to find everything you're not given. So let's go through some examples. First one, in right triangle, ABC, capital letters are angles, so angle A is 40 degrees. And side C is 12. So I'm going to find sides A and B and angle B. So for right triangles, all we have to be given is two things. And we can find everything else. In this case, we're given angle A and side C. Well, the first step you want to do on this, you want to draw a diagram. And I would just draw a standard right triangle. Don't worry about getting the angles or the sides in proportion or anything like that. Just draw a standard one because you will get the orientation of things. Right, so here we have triangle ABC. So remember, as we draw these out, one consistent thing you have is the right angle is angle C, and the side opposite would be side C, and then A and B go either place. Side A opposite, side B opposite. And then we're given that, and this is 40 degrees here for angle A, and side length C is 12. Okay. Well, we can start a lot of places. Maybe the easiest place to start would be angle B. Right? Because you know that angle A and B have to be complements. Have to be complementary because this is already 90 degrees here. And so these must be 90 as well to add up to 180. And so angle B has to be 90 degrees minus 40 degrees. And we get that to be 50 degrees. Right, so that's one thing we found. Now we just need to find B and A. So let's see, and again, order, a lot of ways to do these. Let's find side A next. So let's see, if I find side A, from the angle I know, from angle A, side A is the opposite, and I have the hypotenuse. Well, okay, so opposite over hypotenuse, that would be, that's the sine. So the sine of 40 degrees is the opposite of the hypotenuse. Or if I solve that for A has to equal 12 sine of 40. Remember that the sine of most angles is just an irrational number, and so I just multiply it out, and again I'll just use my calculator to multiply that. So if we take the 12 sine 40, we have 7.7. You can see here that the side length, we had two significant digits, so I'll keep my answer to 2, so it'll be 7.7. Also, check to see, that's equal to A. I should relabel those, right? This was side B up here, or angle B, I mean. Make sure if there's units given, because sometimes there may be units given, you include those. Now let's find side B. Again, a lot of options I could use. I could use the Pythagorean theorem because I have two of the sides already. Or if I look from the angle, side B is the adjacent, right? I have the hypotenuse, so adjacent over hypotenuse is cosine. So the cosine of 40 degrees is B over 12. Or B is simply 12 times the cosine of 40. And if I take and multiply it out, so 12 cosine 40 is 9 point. So again, two significant digits, 9.2. And that is equal to, we said, B. So we have B. And then we found the three things it's looking for. Okay? Okay, let's run through one more example. And then this is the assignment. So example 2. So in this case, in right triangle, ABC, A is 2.73, B is 3.71, and I just the question is to find the remaining sides and angles. Okay, so find the remaining sides and angles. So again, draw your standard triangle with that labeled. Always start there. So we've got C, A, and B. Side C. Side B over here, and B was given, right? B was 3.71. And A is 2.73. Okay. So the difference on this one, I have two of the sides. I don't have any of the angles. And so, we can start a lot of places. If I want to find side or angle, side C, I could use Pythagorean theorem. Right? We know that side C would have to be the square root of A squared plus B squared. Alright, so we can find that very simple to find. I always suggest you do it in one step on your calculator. So if I take square root of 2.73 squared plus 3.71 squared and 4.61, right? We need to round the 0 up to a 1 as we look at 3 significant digits, right? We have 3 in each of the sides. So 4.61, no units given, that's C. And then, of course, I need to find A and B. Well, let's see. So from angle B, I have the opposite adjacent. Well, that would be tangent. The tangent of B has to be the opposite of the adjacent. Well, let's see. As we remember, to find an angle, I would take the inverse trig function. So B has to be the inverse tangent of 3.71 over 2.73. I think I'm going to do it all in one step. Of course, I want to make sure I'm still in degree mode. So let's see, inverse tangent of 3.71 divided by 2.73. Okay, and let's see, the rule was, right, that if I'm to 3 significant digits, let's see my little table I had earlier, if I'm at 3 significant digits on the sides, I go the nearest tenth of a degree. So this will be 53, right, 53.7. So 53.7 degrees. And now angle A is very easy to find because that has to be 90 minus that. So let's see, 90 minus 53.7 is 36.3. Okay, alright, so that's how you're going to work those. The assignment for this section is on page 75, 2 through 20 to even. Do you have any questions?